circuits have a memory? Sequential circuit. Okay, so the block diagram of sequential circuit. Block diagram of sequential circuit. So here it is a combinational circuit, but the combinational circuit doesn't have a memory. So this is output, and here it is input. The present output depends upon the present input. So that is called the combinational circuit. So with the having a memory element, so the output is given to the memory element, the combinational circuits. So it is depending upon the present state as well as the future also as the next state. Okay, present inputs and past outputs. So that is called the sequential circuits. Output depends on only present inputs, that is called the combinational circuits. Output depends upon the present inputs and the past outputs is called the sequential circuits. So one of the most fundamental sequential circuit is latch or flip-flop. Latch or flip-flop. Okay. So actually latch or flip-flop is a bistable multivibrator. This is very important. If you get the theory question from this, definitely you can expect bistable multivibrator. Okay. So it can store the one bit of binary information. It can store one bit of binary information. Binary information that is either 0 or 1. Either 0 or 1. Okay. Now, because of their ability to regain a given state, these elements are used as the storage elements. So first of all, SR latch. So in the latches, the most important one is called the RS latch, or also called as a SR latch, or also called as a set reset latch, or reset set latch. So the most fundamental type of the storage element is SR latch. There are two inputs are there. There are two outputs are also there, present state and past state. So if you are going for the logic diagram of the SR latch, now this is set and reset. The output is having a Q is the present state S Q bar. The diagram of the or logic circuit of the SR latch. So we are using a NOR gates. So this is R and this one is S. The first one output is given to the second. The second is given to the first here. Let us say this is Q here and this is Q bar. What is the truth table? The truth table of the SR latch. You can say that it is a RS. RS are the inputs and the output is you can say that it is a Qn plus 1 is the next state. So it is same 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 0 and 1 1 1 1 1 0 and 1 1 1. See, whatever it may be, if you take that, if the input is 0 0, there is no change. The state doesn't change. You can observe that whatever the values are there, the same values is displayed in the output. So you are giving the yes, present state is 0 1, The present state is 0, 1 when your input is given as 0, 0. So same will be reflected here. I can write it as a no change. No change. If I am giving the 0 and 1, the set value is 1 only. So if I am giving the 0 and 1, so that is equivalent to set. Whatever the value which is given to the input which is given to the set, the output is displayed like this. And here, if you take these two, and this is 0, 0, by why? Because the set value is 0 here. I can say that it is a reset. So whenever it is both are ones and it is indeterminate form. But okay, but you can use a logic circuit if you want to design for the SR latch by using a NAND gates. So here you can give like this. So S here you can use a NAND gate. This is also NAND gate, and here also it is a NAND gate. Okay, so this one is called the reset. This input is given to the output as well as the output of this one is given to the input to the second one. Let us say this is Q and this one is called the Q bar. This is called the Q bar. So here we are not applying the any gate, so there is no control. So that's why we are waiting for the gated SR latch. Gated SR latch. Gated SR latch. In the gated SR latch, we are having an enable input. So in a gated SR latch, we are having a enable input. So this is a set and a reset, and one more input is also there. That is called the enable input. Okay. So with the help of a logic circuit and with the help of a NAND gates, you can see clearly this output is given to the input of this one, and this output is also given to the input of the another NAND gate. So this is a set here, and the input which is given to the second NAND gate is reset. So here we are giving the enable input. Enable input is given like this. Okay. So what is the truth table for this one? If enable input is only one, then only the output will be displayed. So if enable input. So first of all, I am taking reset and set here, and then it is qn plus 1, and what is the state here? So this is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and triple 1. And this is for all the I can keep the enable input is 1. I can keep the enable input is 1 here. Okay. So what is the output state? You can observe that for a 0, 0, what is the output state? So whatever the present status are there, the same will be displayed here, and this is I can say that is a no change. And for these two for these two inputs 0, 1 and 0, 1, whatever the set values are there, you can say that this is the set value, and for these two you can take that the reset values, and for this 1, 1 and 1, 1, so I can say that it is a indeterminate form here. Indeterminate form, I can't say that okay it is an indeterminate form. Suppose if you are giving these enable input is 0, enable input is 0 as it is, whatever the present state output is there, the same will be displayed in the output. The present state, whatever the present state will be output, because there is no change because it has a memory, sir. What is that? If you press the calci and in the calci you mention that 95 until unless if you press the on button. So if you store the AC, so again you can type it as answer equal to So after a half also, if you press answer is equal to, it stores 96. Yes or no? Similarly, same way. So it is having I can say that it is a registers. I can say that it is a registers or a flip flop. Okay. So next one is called the D latch, or also called as a data latch. D latch. Everything is stored in that form of a data. So everything is stored in the form of a data. Okay. So I can say that from the truth table of SR latch, you can observe that if both inputs are same, the output doesn't change. Yes or no? And if both inputs are same, the output may be indeterminate form. But in a many practical applications, input conditions are not required. Okay, so these input conditions can be avoided by making the complement to each other. So this is modified by the SR latch. So this modified SR latch is known as D latch, is known as D latch. Okay, so same, the circuit is won't change, only there is a small change here, and this is also D naught. Yes, this is circuit. You can this output is given to here, and this output is given to here, and this state is Q, and this state is Q bar, and here it is set here. Here it is also reset, and these two are enabled with the enable pin. Now the scenario is comes into picture. So this is called the D is given, and with the NAND gate, so I can give it to this one, or I can give it to the reset. Now the function table is very important. So truth table are also called as a function table. Truth table are also called as a function table. Function table. So if the enable input is 0, sir, so this is D and Qn 0 0. D will be cross, and this is also cross 1, cross 0, cross 1. So whatever the output is there, whatever the present state is there, this is a present state. The same will be displayed here. As I told just now, if you press the 96 in the calci, that is already saved, right? Yes or no? So what is going to the state? The state is having a no change for this one, no change. But here I can say that 0 0 0 1 1 0 and 1 1, and for all these I can put it as enable input is 1. Enable input is 1. If I am taking the D value is 0 0, if the D value is 0 0, I can they say that the output is also 0 0, and then I can say that it is this condition is called the reset condition. If D value is 1, the output is also 1, I can say that it's a set condition. I can say that it's a set condition. Okay, so now see, latches are used as a level triggering, and flip-flops are used edge triggering. So all these are used the level triggering. This is very important. Latches are using level triggering, but flip-flops is a memory element, right? Flip-flops is a, yes, you can use that edge triggering. Yes, if I am giving the clock pulses, this is going to be a clock pulse. So edges, right? We can say take that these are called the clockes. So clock pulses. If it is zero, this value is zero and this value is one. Okay. So we are having a types of triggerings. In the types of triggerings. If you go for the types of triggerings, okay, first one is called the positive level triggering. That means level triggering. So level triggering, we are having positive level triggering and negative level triggering. And this is the first one here. And what is the second one is called the edge triggering. So edge triggering. So A value is positive edge triggering, and the B value is negative edge triggering. Negative edge triggering. Negative edge triggering are response to inputs only and negative edge of the class signals. Okay. So the flip-flop is a memory element. The flip-flop is a memory element. Flip-flop is a memory element. Memory element, it stores one bit of information. Stores one bit of binary information. It stores one bit of binary information. Okay, so it has a two states. One is called either 1 or 0. 1 or 0. Now I am going for the clocked SR flip-flop. SR flip-flop. Only one thing, sir. What is the difference between the latch and SR flip-flop? See here I am taking the reset first. After that set. So the output is as it is, just interchanging these two values. Set and reset are interchange the values. You can get the answer for this one. Clocked SR flip-flop. So S R and this is QN. S R and this one is QN 000 001 and 010 011 100 101 110 and 111. So here I am giving the clock pulses. You can hear the edge triggering, right? It's a clock pulses is like this. So it is going to be increases for all the inputs as I am giving a clock pulses. As I am giving a clock pulse. Instead of enable pin, I am applying a clock pulses. Now we are going to the output. So that is called the next state Qn plus 1. So if set is 0 and set and reset is 0, so there is no change now. This is called the 0 and 1. Now I can say there is a no change. This is the state. And if I am giving 0 and 1, and if I am giving this 0 and 1, so whatever the set values are there, blindly you can keep here, and that is called the reset value. And whatever the set values is there, if you are giving 1 0 and 1 0, these values are 1, I can say that it is a set value. And 1 1 is called the indeterminate form. 1 1 is called the indeterminate form. And also if a clock pulse is increases, you can give at cross, and this is 0 and 1, and this is no clock pulse is applied here, and you have 0 1, so that is called the no changes. Only SR is interchanged, sir. Previously SR is interchanged, that's it. The remaining truth table is same. The remaining truth table is same. So the characteristic table I can write it as the characteristics table of SR flip-flop, S and R, and this one is called the Qn plus 1, 0 0. Then it is present state is Qn, 0 1 is 0, 1 0 is 1, and 1 1 is indeterminate form. 1 1 is indeterminate form. You should find out the K map. So K map for this one. Otherwise, I can write the equation directly. There is Qn plus 1 is equal to Qn plus 1 is equal to S plus R bar Qn. See, this is a value now. Okay. In the K map, you will take one it is a S and another one is called the R into Qn. So R into Qn. So and not only from this table, if you want to get the clear this equation from this table, you can apply from this table SR and QN. You can find out the QN plus 1. So from this you can develop the K map, And after that came up this equation, sir. Whether we have to remember this equation? Yes, sir. This is called the characteristic equation of SR flip flop. Characteristic equation of SR flip flop. SR flip flop. Okay, so like that, you can develop the SR flip flop. Now we are going for the clocked D flip flop. Clocked D flip flop. Only one thing. So what is the difference between the latch and this one? So same diagram, you can take it as same diagram. So this is coming like this. The output of this one is given to here and Q, and this is Q bar. Q and Q bar. Here also one NAND gate. Here also one NAND gate is here, and here also you can give that. So this is called the reset here, and this one is called the set. After that, here I can give the clock pulse. Here I can give the clock pulse. You know that this is a D flip flop. Again, NAND gate is given here. NAND gate is given. What is the truth table? You can truth table. This is very much important, sir. The truth table is important. So clock pulses always you should remember. I can give the positive edge triggering. So positive edge inputs are D and Qn, and the output is Qn plus one. So this is a 0 0 0 1 1 0 1 1 here. And whatever the D value is there, you can project here. If it is 0, 0. So then this state is called the reset state. If it is 1, you can keep it as 1. I can say that it is a set state. So if it is 0, that means clock input is 0 and the clock input is 0, you can D value is any value. So any value, if the present input is 0 1 and this is also 0 1. No change. No change. So finally the characteristic equation from this I can write it as very simple. For a truth table of this one is called the D and Q. If a D is 0, output is 0. If D is 1, the present state is also 1. What is a Qn plus 1? The Qn plus 1 is equal to after K map, the answer is D. After K map, the answer is D. Okay, so in order to find out this indeterminate form or okay, then we are going for the JK flip flop. Okay, the uncertainty in the state of an SR flip flop. Uncertainty. So clocked JK flip flop. Clocked JK flip flop. The uncertainty in the uncertainty in the state of an SR flip flop when S is equal to R is equal to 1 can be eliminated by converting it into a JK flip flop, converting into a JK flip flop, right? So this is S, or here I am going to give the clock pulses. So here AND gate I am giving, AND gate I am giving. So this is called the Q, and this one is called the Q bar. So one input is going to be Q bar here, and another input is J. Here also I am using a AND gate is given to R. So this one is K here. So one more, the Q output is given to the right, where S is equal to JQ bar and R is equal to KQ. This is a modified diagram of the SR flip flop. SR flip flop using a JK flip flop. Now final diagram I can write clearly like this, and this one is called the input is J here, and here also K, and we are giving a clock pulses. The output state is Q, and another one is called the Q bar. Another one is called the Q bar. Okay, right? So if you want to get with the help of a NAND gates, this is one NAND gate. So the output is here Q, and this one is called the Q bar. And the Q bar output is given to one of the NAND gate, and Q output is given to the another NAND gate. And here also you can take the one more NAND gate. Here also you can take the one more NAND gate. So here one input is given here. Here also same thing. And now, so this is going to be a J, and this is going to be K here. So for these two, I am giving a clock input. So this is exactly actually, it is a SR flip-flop, but from this point, from this point, you can take the output so of the Q bar, and from this Q, you can take the input, or you can give the input to the K, or input to the K of the NAND gate. You can observe clearly. So this feedback path is not there in the SR flip-flop. Okay. If you want to draw the truth table for this one, truth table. If you want to draw the truth table for this one, so these are the inputs and output. So here I am giving a clock input J, and this is K, and this one is Qn, and this is Qn plus 1, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, double 0, 1, 0, 1, 1, 1, 0, and triple 1. So you can give the clock pulse is 0 for the first two. So before that, so I can take that, I can take that cross also. This cross also. Okay, that means this is the cross cross, and this is also cross cross. So J, K, and this is called the Qn, and the present state is 0 and 1. The present state is 0 and 1, and this one is called the Qn plus 1. Output is Qn plus 1, and here clock pulse. For these two values, the clock pulse is 0, and for all the values, as I'm applying a positive edge triggered. If you are not applied, the output is only 0, 1. Whatever the present state is there, whatever the present state is there, that is displayed here. If the jk value is 0, 0, and here also the present state, and it has won't change here. And if it is applied as 0 and 1, so 0 and 1, so the output is 0 and 0. If it is 1 0 1 0, that means 1 1. But here you can apply 1 1. So it is a complement of this one. So this is a 1 here, and this has to be 0. Complement of Qn. So the if previously if you take a 1 1, so that is not indeterminate form. That is a indeterminate form. Now here the Qn complement. Okay. Now the characteristic table. So if I am giving the jk and qn plus 1, so this is 0 0 0 1 1 0 and 1 1 here. And for 0 0, whatever the state is there, that qn, you can observe that whatever the state is there, the same present state and future state, next state, both are same. So I can say that it is for 0 0, it is qn, and 0 1 is called the 0, and 1 0 is 1, and this is a complement of this one. Okay, if you draw the K map for this one, characteristic equation of a JK flip flop, characteristic equation of a JK flip flop. So now the next state Qn plus 1 is equal to K bar Qn plus J Qn bar. right? So this is a characteristic equation of the JK flip-flop. All the characteristic equations you have to remember. So what is going to be happen whenever the input is 1 1 is given? So it is going to be okay. So toggle mode. So it will changes to 190 190 190. Okay. So I can say that it is a race around condition. Race around condition. I can say that it is a race around condition. Okay. So here you can take that the clock pulse width is TP here. The clock pulse width is TP, right? If you apply the J is like this, and the K value is opposite to this one. So K, and this is so what is the present state you can observe here. And whenever at this position 1 and 1, if you are both are 1, so it is toggled like this. Here also, in this position also 1 and 1 here. So it is toggled like this. This condition is called the race around condition. The width of this one is called the delta t. Delta t. Okay. Our propagation delay of two level NAND gates. TP is called the pulse width, where TP is called the pulse width, and delta T is called the propagation delay of two level NAND gates. Two level NAND gates. Okay. The J is equal to K is equal to 1. The output is continuously in toggle mode. If J is equal to K is equal to 1, the output the output continuously toggles in that region. Toggles in that region. So that means either it's from 0 to 1 and 1 to 0. So there are three solutions for the race around conditions. So three solutions, three solutions for RAC. Three solutions for RAC. First of all, use of edge triggering. Use of edge triggering instead of giving the level triggering. Okay, and RAC exists when, see, if a TP is greater than or equal to delta T, then RAC exists. This point is very important, ma. This point is very important. It was repeated in so many examination. When TP value is less than delta T, you can make it that we can avoid RAC condition, race around condition. And third one is called the use of master slave flip flop. This is a master slave flip flop configuration. Master slave flip flop configuration. Okay, so coming to the master slave JK flip flop. Master slave JK flip flop. Right? So logic diagram, you can observe that logic diagram here. This is JQ and the KQ bar here. Here I am giving the clock pulse to here. So clock pulse, one more clock pulse is given to. So it is a combining of SR flip-flop and JK flip-flop. So this is going to be a clock pulse now. This present state of this Q is given to the S and Q bar is given to the R. And now there are two inputs. So what is that inputs is called the JK. So this is about the master slave JK flip-flop. So what is going to be output or what is our truth table? You can observe that truth table. So clock pulses as I'm applying J, K, Q, N. J, K, Q, N. So 0, 0, 0, 0, 0, 0, 0, 0, 1. All you can take it as double 0, 1, 0, 0, 1, 0, 0, 1, 1, 0, 1, 1, and 1, 0, 0. Okay, I will take here because I will take master slave output, a slave output condition. So master slave flip flop, or slave flip flop output. This is Qn plus 1, this is Y. So here also I can have 1, 0, 0, 1, 0, 0, 1, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 0, 1, 1, 1, 1, 1, 1. So here you can give the positive edge trigger, negative edge trigger, positive edge trigger, negative edge trigger, positive edge trigger, negative edge trigger, like this. You can give here also positive edge, negative edge, positive edge, negative edge. Okay. For these two types of edge triggerings, I can take this one. So what is here? It is a zero value, and here it is a no change, no change, and it is a one, one. So because 0, 0 means yes, 0, 0 means you can take it as one here, and again it is a 0, 0. I can say that it is no change, and this is 0, no change, 0, no change. So like that, okay, you can apply the positive clock and slave the. So there are two flip flops. One is called the master slave. It's a master flip flop. This is called the slave flip flop. This one is called the slave flip flop. Okay. So latches checks all its inputs continuously and changes its output accordingly at time. But flip-flop samples at its inputs changes its outputs only at a time as determined by the clock signals. And now we are going for the T flip-flop, or also called as a clock or T flip-flop. Flip-flop, as the name itself, it is a toggle flip-flop. Toggle flip-flop. Okay, so directly I will give that already discussion is over. Now this is TQ and QN plus 1. If the input is 0, 0 and 0, 1, 1, 0, 1, 1. If T is 0 here, it is whatever the present state is there, you can write here. If T is 0, yes, present state. If 1 is there, you will take 1, but here it is 2, 1, 1. 1 means you can take 1, 0 means okay. 1 means complement of this one, that is called the complement of 1. That complement of 1 is called the 0. Now T, this is called the Qn plus 1. This is 0 means present state, 1 means complement. 1 means complement. So the equation is Qn plus 1 is equal to T bar Qn plus T Qn bar. So that means T XOR with Qn. T XOR with the Qn. Okay. So this is about the all the flip-flops. All the flip-flops. So asking for a JK flip-flop, for a JK flip-flop, its J input, its J input is tied to its own Q bar output, and its input is connected to its own Q output, its own Q output. If the flip flop is fed The flip-flop is fed with a clock of frequency, 1 megahertz. Its Q output frequency, its Q output frequency will be, Q output will be. Now, so what is the output? That output frequency is output frequency. The formula is output frequency for a JK flip-flop. Output frequency is equal to input frequency by 2. That is 0.5 megahertz. 0.5 megahertz. Okay. You will take the another question. This is also GATE 2002 question on the flip-flop. The frequency of clock pulse or clock signal applied to the rising edge triggered D flip-flop. Rising edge triggered D flip-flop is shown in the figure. Shown in the figure is 10 kilohertz. Previously is given as the JK flip-flop. Now he is giving the, yes, the frequency of the signal. The frequency of the signal available at Q is, so this is a DQ, and here I am giving a clock pulse here, Q bar. So this is going to be a 10 kilohertz. Yes, this is the distance between these two is 10 kilohertz. So the option E is given as 10 kilohertz and the B is 2.5 kilohertz and the C is 20 kilohertz and the D is 5 kilohertz. Yes, just now I told the formula, right? So a D flip-flop, what is the equation for the D flip-flop? Where Q of T plus 1 is equal to D. But from the figure you can observe that D is equal to Q bar of T. D is equal to Q bar of T. So then obviously Q of T plus 1 is also D bar. Normally this is, yes, answer I need ma. So option D, yes ma, option D is correct. Option D is correct. So half only. So you can do it as 10 by 2. 10 by 2. So that is 5 kilohertz. So the frequency is half. The frequency is half. Okay. So this is a gate 2015 set number 2, a Boolean function, f of a comma b comma c comma d is equal to pi of 1 comma 5 comma 12 comma 15 is to be implemented is to be implemented using an 8 is to 1 multiplexer where A is MSB. The inputs A, B, C are connected. The inputs A, B, C are connected to the select inputs S2, S1, S0 of the multiplexer respectively. Zero, 1, 2, 3, 4, 5, 6, 7. S0, S1, S2. This is A, B, C. F of A comma B comma C comma D. This is 0 to 7. Which of the following options? Which of the which of the following options gives correct input to pins 0, 1, 2, 3, 4, 5, 6, 7? In order, the options D 0, D 0, 0, 0, D bar comma D, and the B is D bar comma 1, D bar 1, 1, 1, 1, 1, 1, D D bar. The C is D comma 1 comma D comma 1 comma 1 comma 1 D bar comma D. And the D is D bar comma 0 D bar comma 0 comma 0 comma 0 D D bar. Do it and tell me. Anyone, what is the answer, ma? Yesterday we solved this type of model problem. Okay. Check, check. Uh, Satvik, option B is correct. Option D. Check ma. Option B, not D. Check once. He is giving pi. He is giving pi of 1 comma 5. Option D. Okay, let's check it. 1 comma 5 comma 2 comma 15. Yes, option B is correct, ma. Okay. Now is given as Boolean function f of a comma b comma c comma d is equal to pi of 1 comma 5 comma 12 comma 15. So where small f is equal to sigma m 0, 2, 3, 4, 6, 7, 8, 9, 10, 11, 13, and 14. 13 and 14. So now you can write it as, let us say this is ABC and this one is D here. ABC and D here. So this is D bar and this one is 0 and this is 0 and 1. D bar means 0 and 1. I naught, I1, I2, I3, I4, I5, I6 and I7. First of all, you are taking the even values now. 0, 2, 4, 6, 8, 10 and 12 and 14 here. And here 1, 3, 5, 7, 9, 11, 13 and 15. Now you can mark clearly. 0 is marked here. 0. After that 2, 4, 6, 8, 10, 14. Odd values are 3. Next 7, 9, 11 and 13. 9, 11. So if one thing is marked, you can write it as D bar here, and two are marked 1. 1 is marked again, it is a D bar. 2 is marked 1, 1, 1, and this one is going to be D here, D, and this is going to be D bar. So answer is D bar 1, D bar 1, 1, 1, D, D bar. D bar 1, D bar 1, 1, 1, D, D bar. Yes, B option is correct. Okay, like this you can solve the problems, right? A 4:1 multiplexer is used to implement a 3-input Boolean function as shown in the figure. As shown in the figure, the Boolean function f of a comma b comma c implemented as So this is a GATE 2006 problem. So 4:1 multiplexer. I naught, I1, I2, I3. This is A. So this is 1 here. And this one is 2. There are two selection lines. One is S0 and S1. Either I can say that the AB here. The output is the f of A comma B comma C. The option C is writing as f of A comma B comma C. Sigma 1 comma 2 comma 4 comma 6. So directly I am writing sigma 1 comma 2 comma 6. Sigma 2 comma 4 comma 5 comma 6. And the D is sigma 1 comma 5 comma 6. Yes, ma'am, what is the answer? Anyone? What is the answer, ma? 1 comma 2 comma 4 comma 6. So there are three inputs is giving. What is going to be the answer? Uh, no one is giving reply. Okay. The selection inputs are like this: A, B, C, and Y. And this is 0, 0, 0, 0, 0, 1, and 0, 1, 0, and 0, 1, 1. What is going to be the output? You can observe that output is C, C bar. I think it's a C. Okay. So then I am getting 0, 1, 1, 0, 0, 1, 1, 0. After that A, B, C, Y, 1, 0, 0, 1, 0, 1, 1, 1, 1, 1. So here, what is the output? You can check that. So it is inverted. So 1, 0, 1, 0. So this is the output. For this, you can write the table. This is A bar and this is A, I naught, I1, I2, and I3. So this is 0, 1, 2, 3, and here 4, 5, 6, 7. So mark here 1 is there, and 2, and 4, and 6. So the answer is 1, 2, 4, 6. Based on the input we are giving, so the output will be displayed. That depends upon the selection switches also. That depends upon the selection switches. Okay. You can solve this small problem. The logic function. See here, for 0, 0, 0, this is going to be 7, up to 0 to 7, based on the selection switches and input. You will get the output as, if a 0, 0 is given, that C is also 0. And if a 0 is given, this is going to be complement is 1 for 0, 1 inputs. That means 0, 1 selection inputs. If a 0, 1 selection inputs, then it is complement of the present state, that is C value. So 1, 0, and 1, 0, 0. 1 AB is 1. So obviously it is 1. So 1 is complement C and C bar, C and C bar, C and C bar, like that. Okay. So C and C bar like that. Okay. Your answer is 1 comma 2 comma 4 comma 6. Okay. The logic function f is equal to xy bar whole bar xy bar plus x bar dot y whole bar is the same as A f is equal to x plus y into x bar plus y bar. B f is equal to x bar plus y bar plus x plus y whole bar. C f is equal to x dot y bar dot x bar dot y bar. D none of the above. Okay, what is the answer for this one? Option D. Yes, option D. Okay. Right. Right. So D option is correct. None of the above. f of a comma b comma f of a comma b comma c comma d is equal to pi capital M of 0 comma 1 comma 3 comma 4 comma 5 7 9 11 12 and 13 14 and 15 is a max term representation of a boolean function f of a comma b comma c comma d, where a is the MSB and d is the least significant bit LSB. The equivalent minimized representation of this function is a plus c bar plus d into a bar plus b plus d, a c bar d plus a bar bd, and c is a bar cd bar plus ab bar cd bar plus ab bar c bar d bar, and the d is b plus c bar plus d into a plus b bar plus c bar plus d, a bar plus b plus c plus d. So this is GATE 2015 set number 1. Ismo, what is the answer for this one? What is going to be the answer for this one? Option C. Yes, ma, correct. Option C is correct. What about others? Okay. So this is in max terms, sigma m of 2, 6, sigma m of 2, 6, 8, 10. So write the K map for this one. Sigma m 2, 6, 8, 10. This is AB here, and this is going to be 0, CD, 0, 0, 0, 1, 1, 1, 1, 0. This is also 0, 0, 0, 1, 1, 1, 1, 0. And these two values are 1 here, and here it is 1, here it is also 1. So fold this one. First of all, these two will forms the 1, and this is also 1, where f is equal to. So we have so many problems. That's why 0 is as it is 0, that I can say that is a bar. So this is CD bar. Directly we can write CD bar plus. Here these two also 1. 0 is 1 and D is same D bar. And this is AB bar. AB bar. So now I can write it as A bar CD bar plus AB bar D bar. I can write it as C plus C bar. So C plus C bar means this is C option is correct. So this question is somewhat mistaken, ma. I will modify this one. Now you think and tell me whether you are getting the answer is same or not. So this is B and C value, and this is A value, this is A value, and this is going to be 0. The question was printed as mistake. There are two selection lines, S1 and S0 and S1, and this is A here, and this one is BC are the selection lines, and this is 1 and 0. Now you do it. How you do it? Are you getting the same answer or not? Are you getting the same answer or not? 1 comma 2 comma 4 comma 6. So otherwise directly you can write the equations. Okay, right? So instead of going that also, I can see that BC values are 0, 0, 0, 1, 1, 0, and 1, 1. I can say that is a B bar, C bar, B bar, C, and BC bar, and this one is called the BC. What are the inputs? You can multiply here. So first of all, A is coming like A is coming output I naught. I naught is a A is coming output. So I can say it is a A here. plus after that a bar is I1 is a bar is coming like this plus, and after that input 1 is coming, so 1 is coming 1 into BC bar, and I3 you can take check that it is 0 is coming now, 0 into BC bar, 0 into BC. So answer is a B bar C bar plus a bar B bar C plus BC bar. So I can add here A plus A bar. The term is missing now. So I can take that A B bar C bar plus A bar B bar C plus A B C bar plus A bar B C bar. So now what is the value of this one? What is the value of this one? So this is 100, this is 001 and 110 here, and this is 010. So 010 value is 2 and 110 value is okay, 421 means 6 here, 001 is 1 here, and 100 value is 4. Yes, is it matched or not? Yes, 1 comma 2 comma 4 comma 6. Okay, the question was printed wrong here, so this is A and this one is called the 1 and 0, 1 and 0. Okay, so like that you can solve all the problems. Right, you can all solve all these problems like this. Okay, yes, I am searching for a EC problem. Multiplexer 0100. Okay. A option is also correct. Why? So it is in pi m mode. See, it is a minimum, right? It is not a max terms. It is not a max terms. Check that, check that. Okay. So it is a 4:1 multiplexer to be used to implement the sum S of a 1 bit full adder, 1 bit full adder with inputs with two input bits P and Q and the carry input C input. Which of the following combinations, which of the following combinations of inputs, which of the following combinations of inputs to I naught, I1, I2, I3 of the mux will realize the sum yes. Okay, so solve this one. This is I naught, I1, I2 and I3. The selection switches are S0 and S1, PQ, where I0 is equal to I1 is equal to C input, I2 is equal to I3 is equal to C input bar. The B is this is I0 is C input bar and this is C input. So here C option is given as where I0 is equal to I3 is equal to C input and I1 is equal to I2 is equal to C input bar. The D option here it is C input bar and here it is C input. So my sincere suggestion is to better to solve all the previous year's papers problems which are there for ECE as well as the triple E. So maximum I have covered all type of questions. Okay. So better if one class is arranged, okay, and not required also dual slope and successive approximation type and flash type. Counters. So option C. So option C. Yes, my option C is correct. Option C is correct. Yes. What about others? What about others? Yeah, C option is correct. Satvik, C option is correct. Right? So he is giving the 1 bit full adder. So you know that full adder output. So what is a full adder output? Sigma m of 1 comma 2 comma 4 comma 7. Right? S or no? If I am taking C input bar and C, so this is I naught, I1, I2, I3. You know that first even values you will take 0, 2, 4, 6 and 1, 3, 5, 7. So you can mark and you can close this one. And what is the answer here? One you can circle down, 2, 4, and 7 here. So all are. So here you will get the C input. C input. This is C input. Sorry, this is C input bar, and this is C input bar, and as well as the C input. Okay, the answer is over. Just wait, ma. I am uploading the document in the Google Drive. So I will send in the chat box. Wait for 1 minute. Triple. Yeah, I forward in the chat box. After downloading, give confirmation. So can I can close the session. Okay, ma. I'm closing now. Okay. Check the diagram. Diagram you will check. Okay, diagram you will check. So based on the diagram we will take. So previous diagram is different. Here the previous diagram is different. I mean input C is different.